So this is another quick iGCSE summary video for an intro. So we're looking at key mass in this unit for momentum as being the mass times the velocity. Momentum has the symbol P. That's what we usually use, lowercase. And of course, you've got M and V for mass velocity. Force would be the change in momentum over the time taken. Well, that's mv. So V would be your final velocity, take initial velocity divided by time. Sometimes that formula simplifies. So if I've got mv, the final velocity is naught, we just have F is minus mu over t, which makes it quite a lot easier. Calculations, you need to be able to do P is mv, so mass of an object times its velocity gives you momentum in kilograms meters per second. We need to be able to think about impact forces. So F equals ma, which is from a previous unit. A is v take u over t. I need to substitute the a out of the first equation. You can see the a is the same to give me F is m v take u over t, which is the original form we've got at the top. So you need to be able to understand how impact forces work. And of course, your impact force would be from your change of momentum over the time taken. So of course, if I have an airbag or a crumple zone in a car, the rate of change in momentum then is smaller. So it's all about increasing time because the mass of the car you can't get rid of. So you have to somehow make the time longer, and that makes an FT graph have a smaller maximum force, a smaller peak. Newton's 3 laws of motion, which we've already dealt with, come into it as well. So velocity of a body remains constant unless the body is acted on by an external force. So resultant force is naught is law 1. Law 2, second law, so the acceleration of a body is parallel, directly proportional to the resultant force F, and inversely proportional to mass m. So F equals ma, or F over m is a, of course. Third law, the mutual force of action and reaction between two bodies, i.e. body A, body B, object A, object B, is opposite collinear. Collinear means in a line, so force A equals minus force B. We've also got elastic collisions to look at as well. So imagine we have two trucks, and so the red truck has momentum, hits the blue truck. The trucks link carry on at a lower speed. We have to think about that the idea that momentum is conserved at the start and the end. So I set up a formula where the mass of the red truck times the velocity of the red truck at the start, plus the mass of the blue truck and the velocity of the blue truck at the start, which could be 0, but we're going to put it in our formula anyway, would equal the mass of both of them, because remember they're linked, times the new velocity. Now, if you know certain things, you can work out something that's left over. We also need to do explosions, which is bullet explodes or is fired from a gun. The bullet and the gun have different masses. They share the momentum and velocity of the explosion. Momentum at the start and the end is naught and conserved. So naught would equal mass bullet times velocity of the bullet plus mass of the gun times velocity of the gun. I move one to the other side, and then one becomes the negative of the other, which takes care of the velocities, because obviously they are going to be opposite, not equal, because the masses are unequal. So the object with the biggest mass goes slowly. The object with the smallest mass goes quick. So there you go, projectile motion. So that is momentum.